All right, so as I mentioned, there's going to be stuff here that you're not going to need to write down, but I still want to kind of talk you through it. So we're still working on skills. And in particular, there's 3 skills that we're going to be working on over the course of this project, one of which, at this point, you should have already mastered. Most of you have had several opportunities to develop a scientific question that addresses some sort of correlation. And a correlation is when we don't know why, but we see something change predictably when something else changes. And so in the case of like our plant study, we were looking at, what were we looking at? What was our plant study? I don't even remember. We were looking at were we looking at the white alder leaves, the health of the leaves and the width of the trunk? So we don't know why, if there was a connection between the width of the trunk and the health of the leaves. We don't know why, but we saw that there did appear from our data to be some sort of a connection where there were certain trunk widths that looked like they had healthier leaves and certain trunk widths that looked like they had less healthy leaves. Don't know why, but that's a correlation. One thing seemed to be changing predictably as another thing changed. And we've had a bunch of practice with this. For today, I'm just going to give you the question. But I still want you to think about like where that question came from. It's one that I developed, but I followed the same process, and I'll walk you through that very briefly so that you can kind of reinforce it. And then these 2 skills, design a study and accurately and carefully set up a study, those are skills that we haven't started working on yet. So the aquatic macroinvertebrate study that we're doing, this is going to be our first plunge into thinking about these things, and I'm going to introduce it by doing it for you. I'm going to set the whole thing up. I'm going to tell you just what to do to design a study to answer a scientific question, and we're going to set up our data collection in a way that is going to give us potentially at least meaningful answers if we all do it right. And down the road, you're going to have an opportunity to do this as well. You're going to have an opportunity to do both of these things while we're talking about ecology, because we're going to look at lichens, and you're going to have an opportunity to do this throughout the year as we make other investigations of things like enzymes and DNA and all the stuff that we're going to be looking at over the course of the year. Much of it is going to be driven by your own questions and how you figure out how to answer them. So you'll be working on these skills much more, but for today, I'm just going to kind of lay it out for you. So our question, and this is one that I want you to write down: what is the relationship between the diversity of aquatic macroinvertebrates and the speed/depth of the water in their habitat? So if you think about our framework, our framework for coming up with a question was like kind of look at the main thing that you're thinking about. The plants, we picked a plant, white alder. And for this, the main thing we're looking at, aquatic macroinvertebrates. And then we thought about, well, what are some things that could interact with that white alder? And we thought about, well, there's like the trunk is part of the white alder, so that's something that we could look at. And we thought about things like bugs, we thought about things like soil, we thought about things like the creek. And in this case, my second thing that I thought of was the water. We got aquatic macroinvertebrates, and they interact with the water that they live in. And then the next step is to think about what can we measure. And with the white alder, we ended up making 2 measurements about the white alder. One, looking at the health of the leaves, one, looking at the width of the trunk, and that's perfectly reasonable. But in our case, what we were looking at, or in this case, what we're looking at is the diversity of aquatic macroinvertebrates. That's what we're going to measure about them, and I'll come back to that in a second. And then the speed and depth of the water. So we're looking at some measurement about the aquatic macroinvertebrates, which is their diversity. And this is one that you all have an intuitive understanding of. Like, like diversity, there's kind of more, like there's more something, variety, something. But it turns out that in biology, there's something specific about diversity. There's a specific way to measure it, and we're actually going to come up with a number. We're going to quantify diversity. and we'll get a number between 0 and 1. And the closer the number is to 1, the more diverse that population is. And so we'll look at that measurement that we'll show you how to do next week. And then the speed and depth of the water, and this is weird because it looks like two things. It looks like we're measuring two things about the water, but actually we're not. Because in rivers and creeks and streams, it turns out that if the water is moving faster, it's going to be more shallow. If it's moving slower, it's going to be more deep. The physics determines that, so we don't have to worry about whether we're getting fast and deep or slow and shallow, because we're not going to. We'll always get fast and shallow, and we'll always get slow and deep. So we're really investigating two things at once because these two things are sort of locked together. What we're gonna do, and this part you don't have to write down, but just sort of file this away. What we're gonna do today is we're gonna get a bunch of leaves, and we're gonna attach them to a brick, and then we're gonna get that brick in the water, and we're gonna put our bricks in places that are either fast and shallow or slow and deep, and we'll have a variety of places so that next week when we look at our data, we'll have a bunch of information from places that were slow, deep habitats and a bunch of information from places that were fast and shallow habitats. And Mr. Barron next door, his classes are doing the same thing. So potentially we might actually combine all the data, not just from our class and my other biology class, but from all of the classes together. When it comes to the data collection, we're gonna just use visual observations. This is something you're gonna do today. You're actually gonna collect data today because you're gonna determine where to place your brick, and that's gonna determine one part of our data collection. So we're gonna have two categories for water, fast and shallow, slow and deep. And you'll know today which category your brick is placed in. So one of the things that's important is that you remember that, because if you come back on Tuesday, you go get your brick and you bring it in and you do your analysis, and then I'm like, well, was your brick in fast water or was it in slow water? If you can't remember, then your data isn't useful. You've got to be mindful of the fact that we're doing some data collection today. And then for the aquatic macroinvertebrates, this we'll do on Tuesday, and we're looking at two things. One is, which types do we see? And we have 5 types that we know, right? We have mayflies, stoneflies, true flies, caddisflies, and snails. And then there's a bunch that we're just gonna put into the other category, some of which we've seen already. We saw some alderflies in the other class. We haven't caught any, but we often will get juvenile crawdads, like little ones. So when you come back on Tuesday, it's possible that you'll have a little crawdad crawling around in your leaf pack. We may see some other organisms as well. Has anybody caught one of the little sculpin fish in here? Have we seen any of those? Okay. Yeah, so those aren't aquatic macroinvertebrates, so technically we wouldn't count those, but we'll probably see those in our collection at least at some point. And then we're gonna count how many of each type. So you're gonna keep a tally. And this is gonna be something where we're gonna have to work together as a class because every organism needs to get counted. And some of you are gonna come back because of where you put your bricks. You might find that you just don't have that much. You may unload your bricks and do all the work to look at the organisms and you're done. You've counted them and you're done. But then there's gonna be somebody else, and their bucket is gonna be full of organisms. And so you're gonna count yours, and then we'll all work together to help everybody else complete their counts. And ultimately what we'll have is a tally of these things, how many types we see, and how many of each type. And what we're gonna do with that is we're gonna put together a data table, and the data table is gonna have 2 columns, just like the data table that we looked at for the plant study. One of those columns is gonna be the habitat. And this you should just jot down. This is just gonna be a real quick thing to write down. And the habitat, and there's gonna be water that's slow, and there's gonna be water that's fast. And then I'm gonna show you how you can find the number for diversity. So you're gonna have a habitat type, and then you're gonna have a diversity. And the number for diversity is gonna be between 0 and 1. And this is the data that we're gonna evaluate. So when you analyze your data, when you interpret it, we're gonna be looking at what's the connection between these habitat types and this diversity. And if we do this well, the chances are real good that we will see a pattern. In the past, we almost always do. It's not guaranteed, but we usually do. And it relates to the pollution sensitivity that you all have already looked at for your aquatic macroinvertebrate posters. So it turns out that the connection between this water speed and the diversity of organisms in general is tied to water quality, really. It's tied to the sensitivity that these organisms have to poor water conditions. When we answer our question, we're gonna look at this biodiversity, and I just want you to write this word down just somewhere in there and then flag in your brain that you don't really know what this is yet. It's, you know, like in a sort of general sense, but it's not something that we have specifically talked about, and there's a mathematical formula for figuring it out, but we're gonna calculate that. Then we're gonna make the usual summary data tables and graphs to analyze our data and answer our question. And then we're gonna add one more thing, and I want you to write this down, and that is that we're gonna use statistics to evaluate whether our data is meaningful or not. With the plant study, we didn't do this. So this is gonna be an added piece. And what statistics do is they tell us how likely it is that the patterns that we're seeing actually like are real, and we would continue to see them if we were out in nature, or if it's probably just a coincidence, if it's probably just like something random. So for example, if you went outside right now, there's a chance that you would see a little baby oak tree. And if you measured the height of it, it might be like smaller than you. And then if you walked a little bit, you might see another little baby oak tree, and maybe that one is smaller than you as well. But we all know that oak trees are not all small. If you only look at 2 of them, there's a chance that just randomly you might look at 2 that are kind of small. If you were to look at 3, 4, 5, and you kept seeing small ones, then you might be thinking, okay, well, all these trees are small. And then if you went up into the hills and you started looking and all you saw were small oak trees over and over, and then you'd be like, okay, these things, they've got to be really small. The more data you collect, the more sure you are that any patterns you see are accurate. Now, we all know that in real life, what's going to happen is you're going to see some small oak trees and you're going to see some larger oak trees. So how do you know when you've looked at enough oak trees to definitively say, okay, they're about this tall on average? And the answer is we use a little mathematical magic trick called statistics. And what statistics does is it uses a whole bunch of patterns that we've already observed to tell us you need to get more data, or you have enough data to kind of like make some sort of a conclusion here. And I'm gonna show you how to do that. You'll get, with statistics, a number, and that number tells you simply, is this pattern likely meaningful, or is this pattern likely a coincidence? And that we'll walk you through next week. Okay, and so the next stage here is going to be that we're going to make these leaf packs that I told you about, and then we're going to get them put out into the creek. And so the leaf packs, this is where, so we're talking about like how to design a study. One of the things that we got to think about when we design a study is that really what we want is the only differences between the places and the bricks that you all use should be the kind of water that they're sitting in. What we want is to have a whole bunch of identical bricks with identical leaves, everything as close as the same as possible, so that any differences we see, we can say, well, that's because of the water, all right? So if you all went out and some of you got like 2 or 3 leaves and some of you got 50, and some of you got leaves from some species and some of you got leaves from another species, and then some of you tied it on by wrapping like 50 yards of string around it, and some of you like barely tied it on at all, then when you come back, we don't know if any differences we see in the aquatic macroinvertebrates has to do with the water that those bricks were in, or the kinds of leaves you used, the number of leaves you used, the presence of a whole bunch of string or the absence of a whole bunch of string. So we need to standardize our bricks so that when they come back, we can say, well, the bricks were all the same, the leaves were all the same. We can be fairly certain that what we're seeing here has to do with the water habitat, right? The habitat rather than the bricks themselves. So here's how we're gonna do it. The first thing is, ideally, you'll work in groups of 3. And that's just because it turns out that it's probably easiest to do this as a 3-person job for a variety of reasons. The hardest thing about this is getting the bricks, is getting the leaves tied onto the bricks. And so it's kind of helpful to have a couple sets of hands holding leaves and one set of hands like working the string. And if you end up working in a group of 2, that's fine. If you, you shouldn't work alone though, and you don't need a group of 4. And as I previously mentioned, those of you who have to leave earlier, make sure that you're working with at least 2 other people who are gonna stay here. Don't abandon one person with all of the work when you leave, whenever you need to. And you're gonna gather leaves, and what we're gonna do is look at we'll get 3 different kinds of leaves so that we have sort of a variety. And then we'll get the same amount of each kind of leaf. So everybody's gonna come back with 20 white alder leaves, with 20 Pacific dogwood leaves, and with 20 Oregon ash. That is not how you spell Oregon. And for those of you who don't, yeah?
Is it fine if we abbreviate the?
Yeah, for sure. Yeah, abbreviate to your heart's content. These notes are for you. Yeah. So for those of you who don't remember, the white alder is the one that has the cones and catkins. And you don't need to collect the cones and catkins. The leaves that you get are just gonna be leaves. So the white alder leaves are kind of small and they sort of look like this, right? But look for the ones that have the cones and catkins on the branches near them. So if you find a tree and you see cones and catkins all over it, then that's a white alder. Collect 20 leaves from that. The Pacific dogwood are the ones where if you rip them in half, then they do the, like those strands kind of hold it together. And you don't have to rip them in half, but if you go find plant and you do the dogwood test and you see that, oh yeah, this one would do that, then get 20 leaves from that plant. And the Oregon ash are the trickiest ones because the Oregon ash are the ones that had leaflets, and they can have like 5 occasionally, usually 7 or 9, sometimes even 11 leaflets, but they're the ones that look like this. You have the leaflets on opposite sides, and then there's one at the very end. This is what an Oregon ash leaf looks like, and that's one leaf. So when you come back, don't just take one of these little things and get 20 of those. You want 20 leaves that look like this, 20 leaves that look like this, only not necessarily torn apart, and 20 leaves, big leaves that look like this. You're gonna have a lot of green. And you can collect them. There's the trays back there that you can collect them in, or you can just hold them. The students yesterday were just holding them, and that's fine. Ideally, you would get leaves that are on the ground, or they look like they're about to fall off the tree. You can take them right from the tree. And if you get like green ones, it's not the end of the world, but this time of year, these plants are working hard to like shore up their defenses for winter. all 3 of these plants are gonna drop their leaves, and then they have to survive all winter long on stored energy. They're using their leaves now to store that energy. If we take a leaf that's kind of yellow or red over on the ground, then it's not being used by the plant. So we're not hurting the plant at all. If we strip the plants of green leaves, then we're potentially making it more difficult for them to store some more energy and nutrients over the next couple of weeks. So just be aware that that's part of the plan. Okay, and so what I'm gonna do is I'm gonna stop here, and I'm gonna ask you all to get in groups, go get leaves. It shouldn't take more than like 10 or 15 minutes. You don't have to go beyond the area by the quad, so you don't have to go all the way out to the tennis courts or anything like that. Just stay in this area, the creek by the quad. 10 or 15 minutes, come back with 60 leaves. If you work in a group of 2, then you need to divvy these up so that you end up still with 60. Groups of 2 don't come back with 40 leaves. Groups of 2 still need to come back with 60 leaves, okay? Any questions before you head out? Okay, let's get rolling.